All right, good morning, everyone. Thank you for joining us for this week's edition of the Long Coffee Break. My name is Chris Visconti. I am a sales engineer on the hydronic and plumbing team here at Long. And this morning we are very excited to have Rick Lyles with Sellers Manufacturing joining us. And Rick's going to talk to us a bit about rapid response immersion fired boilers. Rick, take it away.
Thank you, gentlemen. We appreciate your presence and you giving us your time today. We're excited to share about Sellers and our immersion fired boilers. It's not a new concept. It's been around a long time. It's just that a lot of people are still unaware of Sellers. So we began in about 1931 building immersion fired boilers. We built a lot during World War II for the U.S. government. All still immersion fired. They just happened to be for domestic hot water. It's individual burner nozzles firing down of each boiler tube. So it's a truly unique design. It allows us to do some things that we think are pretty special. So it's a single source burner boiler package. Sellers builds the burner. It is a premix burner. In the modulating choices that we have, we use linkageless burner technology. We work mostly with Siemens, but we are definitely the leaders in multi-flame combustion technology. As a matter of fact, I don't know anybody else that's trying to use this same technology. It allows us to do high performance and low emissions. So our normal emissions are 50 ppm, but we can do 30 ppm without any flue gas recirculation at all. The burner is completely test fired at the factory. So before it ships, we run it through its paces. We send out a test report with it, with the O&M manuals to the field, so they can see what we were able to achieve in the shop. Since the burner and the boiler are manufactured by Sellers, it gives you a single source of responsibility for both the boiler and the burner. You can see the nozzles there. As the premix comes through, it's distributed to each nozzle so that each nozzle burns at exactly the same BTU. And the black pipe that you see there is the ribbon pilot that lights all those nozzles. It allows us to do a couple of things. Number one, we are able to use more of our heating surface as the primary. So in a Sellers immersion, we get about 50% of the heating surface used as the primary. So that's about 50% of the way down the tube. Each tube is the same diameter, made from the same material. So it's the same thickness, and they are all the same length. So that uniformity, along with the uniform BTUs that are put in the tubes, gives us a uniformed expansion. So we don't have thermal stresses where they're pushing or pulling back and forth. If you look at the bottom, it's just a diagram of anybody's 3-pass boiler in this case, and they are only able to use between 5 and 14% of their heating surface as primary, and that's just inherent in their design. So they fire everything down one Morrison tube, and then try to make that hard left turn to the second pass of tubes. So keep in mind, everything is uniform in the Sellers. So if you notice here, just a cutaway, we have a nozzle that is ignited obviously by the pilot. So if you go and look at some of the movies that we have here at the end of the presentation, you will see that burner lights almost instantaneously. And so every tube sees the same amount of flame. About 50% of the way down, we start to lose a little bit of the velocity. And so we use what we call a heat extractor in the last 50% that just keeps the swirl going so that we get good heat transfer. One of the other advantages inherent in this design is that velocity and the swirling motion inside the tubes also clean any stagnant gases and combustion air that didn't fully ignite as it went down the first time. So it just kind of flushes it all out. Just the benefits of a single pass design, we can go from 50-degree cold water to 100% steam output in less than 20 minutes. So 100% steam at 100% of the PSI you're looking for in less than 20 minutes. And we can do that without thermally shocking the boiler. We give a 20-year pressure vessel warranty against thermal shock. And what sets us apart is we do parts and labor on the pressure vessel warranty. Because of this design and the tubes that we use, we're able to accomplish somewhere around 40 to 50% space savings. So 300 horsepower versus 300 horsepower, there's a substantial savings, not only in the cubic feet required, but in the square feet required. I mentioned that we can do 30 ppm NOx emissions. That is basically a retuning of the burner and does not require that we use flue gas recirculation. It's not unusual for us to get requests for parts on sellers boilers that are 40 or 50 years old. So we get long life expectancy. We have listed here the enhanced safety, and I'll show you that feature in just a minute, but we are built to ASME code with third-party inspections. So the burner, the firing tubes that we use are XID tubes. They've been standard since 1996. What that allows us to do is to gain some of that swirl that we mentioned earlier, but also extra square footage of heating space in the XID tubes. All of our competitors can use XID tubes, but to my knowledge, nobody has standard on them as sellers. But it is what gives us the advantage of being smaller with our footprint because of the extra firing square footage that we have. The thermal stress points of a multi-pass boiler are fairly obvious. Everything, if you look at the cutaway on the left, everything is firing down the Morrison tube at about 3,600 degrees. And then as you get to the end of the Morrison tube, you make that hard left turn into the second pass tubes. The Morrison tube is considerably thicker, as is the intermediate head, and the heads on the vessel itself are all very thick, much thicker than the second and third pass tubes. And so what happens there is the Morrison tube tries to grow as it's firing and it gets hot, and it tries to pull those second pass tubes with them. So one of the problems with a standard design is that you get tube cracks there at that intermediate head. That's one of the routine things that have to be fixed fairly often. You can see that the second pass is about 1,800 degrees, and the third pass in this case is about 350 degrees. You get large temperature drops, and then the dissimilar stress sets up the issues with a multi-pass boiler. Sellers does not have that problem because, again, everything is uniform. We give the correct amount of heat into every tube, and then it's one pass through. Even with one pass through, our efficiencies will match what our competitors' efficiencies are. The other thing that is nice about our design is it gives us thicker gaps between the tubes, so we get more metal between our tubes with our design. Just an example of a floor space footprint. We took a typical 300 horsepower boiler. It's about 1,435 cubic feet. And seller's 300 horsepower is about 769 cubic feet. So it is a huge reduction in size. The other thing that I'll point out is in the seller's picture there, you see the green. You do not have to have tube access on both ends. The burner door will open. You'll have direct access to all the tubes, or you can access them from the tail end of the boiler by taking the the combustion relief door off, and you have access to the tubes there. You do not need both. You'll also notice there in the bottom picture, there is a square footage saving on the footprint as well. The problems with the multi-pass boilers is that when they have an explosion, it usually starts in the fire tube area or in the Morrison tube area. That Morrison tube, you see in the pictures on the right, that's one where the Morrison tube has failed. And the one in the bottom picture there shows another example of a Morrison tube failing, and the boiler is actually outside the building. So the fire tube explosions are violent when that happens. With the cellars, because of our design, it's because of the immersion technology and the single pass design, we can put relief doors on the tail end of the boilers that will relieve the full capacity of the fireside gases. So we do not have a failure that's an explosion. The door simply pops open. The operators will reset everything, check out what caused the burp or whatever caused the door to open, and then put the boiler back in operation safely. The other thing we do not have at cellars is we do not have refractory. Refractory is a high maintenance thing. It's usually required every 5 to 7 years that you refurbish the refractory. It takes about 7 days of your boiler being down, lots of expense, lots of labor. It takes about a full day to cure it once you can put fire in the boiler before you can actually bring it back up to full capacity. So our unmatched warranty in the industry, our parts is pretty much similar to most everyone. We pass through the parts warranty from the OEM and suppliers, but the burner is 5 years from the date of shipment. That includes the materials for the burner, but does not include labor. And then the boiler shell, as I mentioned earlier, is 20 years from the date of shipment and includes all materials and labor necessary to repair. Sellers has authorized representatives all around the country and in Canada. We also have several mechanical service companies who are authorized to work on cellars. We routinely have training that happens to be going on today at the factory. So we do have a support system in place. Don't forget, I mentioned that we had complete factory fire tests on all the units. If you, I won't go through that because that's for a contractor. Here's an example of some of our successful projects, people who use our boilers. We do not have any distilleries on here, but the distilleries widely use cellars. And the reason they do is because of the ability to turn the boiler off at night and come in 20 minutes early before they want to make product the next morning and fire the boiler up. You don't have to let it stay warm overnight. So what are the advantages? Just a recap. We can go from 50-degree water inside the boiler to full steam output in under 20 minutes. We believe our maintenance costs are drastically less because we do not have any refractory, and we use mostly readily available parts. We have very few proprietary parts. I mentioned earlier our parts per million on the NOx. That's becoming more and more and more important around the country. Our fuel options are natural gas, propane, and methane gas, or any combination of that. Single source responsibility for the burner and the vessel. And then we have over 85 years of experience providing the solutions in lots of applications with this boiler. So the total cost of ownership, we believe it's drastically less. The very first thing is we reduce the warm-up fuel costs and the time to warm it up because it doesn't take us 4 hours. Conventional boilers take about 4 hours to get up to temperature. No refractory, mentioned the efficiency, I mentioned minimal proprietary parts, and I also said that on our modulating boilers, we use Siemens. So we have no thermal shock, which eliminates tube and tube sheet repair costs. We've got a couple of movies or short clips that you can look at on the Sellers boilers. You can get that information from your salesperson. Thank you very much.
Thanks, Rick. Thank you very much for sharing a lot of great info on the unique Sellers product. As always, if you have any questions or need any additional information on the Sellers product offering, please reach out to your Long sales engineer. Please join us next week for our last coffee break presentation before the Thanksgiving break. Lindsay Flater will be educating everyone on the value of Mars air curtains. Thanks again for joining us, everyone, and have a great rest of your week.